Hi guys, and welcome back to this lecture 14, our final lecture on real-world coding examples using PL/SQL. How crazy is that? If you will recall, in our last lecture we introduced the concept of packages, how these black boxes can be used to hide corporate secrets as well as hide complex logic and programming structures from inexperienced programmers. In this lecture we're going to move forward and look at some of the subroutines within our package body, and in particular two really nice ones that you're probably going to want to add to your collection of, hey, this is great code, keep this stuff. One which creates and sends an email using the SMTP and TCP IP utilities, and a second one which registers a user device using the user context function. Great little tools, and ones you're, like I said, really going to want to put in your toolbox as standard code moving forward. So let's jump on the inside and take a look.
Okay, let's go ahead and open back up our user management package body and start to study its components. Looks like we begin with a locally scoped data structure, which assumes that same structure as a row from within the users table. Now, every book on structured programming techniques and every college professor teaching you about software development is going to tell you about the dangers of using global variables. Yes, they can be a problem, but not for the silly documentation and scope issues discussed in academia. They are really only a problem when it comes to concurrency. Let me explain. Package variables are specific to a session. As such, 5 different users of the user management package should each get a separate copy of this user data structure. Similarly, good programming practice would suggest that the calling routines start and commit each transaction as it's realized by the database. All right, now the bad news. Opening a new Oracle session is expensive with respect to processing time, so most well-designed web applications are going to open and then maintain a set of database connections and thus their associated sessions. These globally defined session variables are also being kept around for an extended period of time. Now, what happens when some junior programmer forgets to commit a complete transaction and a second user comes in on that same session? Trouble. Potential mess. Solution? If you're going to use global variables as I do here, ensure the transactions are atomic by writing those commits into the actual expose routine themselves. Similarly, if an exception is thrown, precede that exception with a rollback command. We don't live or work in an academic world, so we get away with using globals. We just need to be smart about using them properly. Okay, moving on to our first locally scoped procedure, audit user change. Now, Oracle has a whole bunch of audit capabilities, and we could just very easily turn those guys on and we would realize the same business function as this little procedure here. Why are they generally not enabled? Because they can really slow down performance, especially if you're doing a lot of updates. Solution? We write our own little auditing pieces, enable them on our most secured and delicate parts of the database. Here, of course, we're talking about storing usernames and passwords. We want some kind of auditing going on. So the common practice is to simply make a copy of the to be audited table, and then a column is added for when the change occurred, and yes, not shown here, and a column is typically added for who made the update. Here's the little known ugly secret. Most online applications do not uniquely log each user into the database. As mentioned above, a pool of database connections is maintained and shared by the web server, and users all come across on those common pooled connections. How do you keep everybody straight? Well, we set each of them up with a session variable on the web server, typically their user ID, and they carry that around with them through all the forms in the web-based application. Each time they hit the database with an update, the user ID session variable from the server comes along. Normally you add this user ID variable along with a date variable to each audit table and you've got it. Ta-da! By the way, that session variable lives on the web server, and how it gets passed to the database is very much a function of the web server software and the calling programs. IIS running .NET is going to look very different than Apache and Java. So what I've done here is just avoided the associated confusion. How will you use it going forward? Just Google your configuration of software. There'll be tons of examples out there, and once you see it, it's relatively easy. Well, before we move on, remember that this locally scoped routine must precede any publicly exposed routine which might call it of the package body listing. If not, you'll get that out of scope error, and it's a tough one to find. All right, moving on to our calc password strength function. Now we've moved our old buddy here out of the regular schema object library and into this package behind the black box walls. Cool, now nobody can steal our ultra secret algorithm for password strength. All right, probably not too big a deal here, but if this is the recipe for KFC chicken, then we probably would want to be a little more concerned and hide it away. Every business has secrets. In Oracle, those secrets should all be nicely wrapped behind a package black box signature. Alternatively, let's say nobody cares about exposing this logic. Do you want a junior programmer attempting this code? If the answer is no, then wrap it behind another simpler procedure and only expose the simple one to the junior programmer. By the way, you guys are no longer junior programmer, PL/SQL programmers in my mind, because you've seen and now are able to thoroughly understand the logic in this routine. Okay, let's move on to the check password history function. First off, why did I write this guy as a function and not a procedure? Answer, it really doesn't matter. I could have done it either way. I just normally write functions because I can then use the with conditional logic in the calling routine. Either way is fine, and the option is completely yours. Just because I do it this way doesn't make it right. Anyway, not much going on here other than the select statement in the loop. Wow, definitely not going to ask a newbie to write that one. Would you have known how to get the superset of all records from those two tables? Surprising how few SQL coders know about the union all, and intersect operators. Oh, by the way, did you notice how I don't even expose errors from my locally scoped routines? Normally, I have my standard SQL code and SQL error message functions in there during debug, but then comment those guys out for production. Again, no need to even expose the names of these hidden routines to external eyes. Wow. Now, having said that, I better go back and check that I commented all these guys out. Just like me to say something like that and then miss one or two. Yeah, I'm getting old, I forget stuff. Remember our out-of-scope discussion? If I comment out these local exception handlers, what happens to the associated errors? Of course, they float up to the calling routine until an appropriate error handler is located. Moving on now past the check username function, go ahead and check that guy out at your own time, but there's really nothing going on there, so we're going to skip him here. Next is the create security prompts function. Again, he could have just as easily been a procedure, but we already discussed my preference for functions, no big deal. Anyway, check out my use of dynamic SQL and the execute immediate function with bound variables. Clever, Rick, very clever. But isn't the commented code cleaner? Sure. I wanted to make an example using dynamic SQL in action, so that's really why I did it this way. Our next black box procedure is used to send emails to people who've forgotten their password. Truth is, I would normally create a package of common utilities and actually expose this procedure to the public in that package. Additionally, I would typically overload this guy such that more sophisticated programming languages could simply pass it a structure. Here we keep it hidden for the sake of an example, but as I said, normally this guy would be a general utility package and made available to anybody who's coding PL/SQL. Anyway, the thing to notice here is the use of the util SMTP and util TCP packages. The SMTP utility, of course, exposes a bunch of routines which allow you to open, send, and close an email. The TCP utilities, of course, allow you to send messages across a TCP/IP network. By the way, anybody an engineer out there and actually know what that boundary constant is all about? Been writing and using this same type of procedure for years and have never understood what that guy did. Again, what software guys don't know about networking would generally write a book. What is the good news? I know this guy works well because I've been using variations on this theme for a bunch of years. Talk about real world example. Please feel free to grab this one and stick it in your old Keep This Good Code collection because it certainly is. All right, now let's jump down to the register device procedure. As I say here in the comment, Oracle has a very nice device fingerprinting solution. Bad news, it's an add-on. Ka-ching, extra money which very few organizations want to spend. Good news, we're writing the poor man's solution here with this code. Again, talk about a real-world example. This is definitely another piece of code to add to the old Keep This Good Code collection. By the way, did you notice how we're able to leverage the syscontext function? As I mentioned previously, Oracle supplies about 1 million built-in functions and packages. Learn how to leverage those guys to your advantage. No wheels get reinvented on your watch. Okay, we now move down to where the public routines are defined. Not too much going on here once you read the code. Please do note, however, how the two overloaded routines are handled. The only real difference is the setup of the local data structure. No need to reinvent the logic wheel once you've got it working with one signature. Just set up the same logic under the second, the third, or the nth. Net, only thing we're typically changing with multiple overloaded procedures is how we pass parameters. Once the processing actually starts, everything should remain equivalent. Also, as we were studying these public routines, did you notice how we passed a collection of possible issues back to the calling routine? Pretty common practice. Rather than throw a bunch of error codes, just pass back the actual issue strings and let the calling routine display them to the user. Oh yeah, one more thing. Check out the use of the decode function in our create user procedures. Sort of works like an inline if then else. If you're not familiar with that function, Google it because it's very handy. All right, that pretty much wraps up our discussion of the user management package. Please go ahead and look over the rest of the code, but please also understand that this package is far from complete. If this were going into production, we would have sat with an analyst or the users and spec'd out a bunch more routines before, both exposed and hidden. Anyway, this has been enough for our little example here, so I'll catch you on the outside.
All right, and thanks a lot for sticking with us on that one. I know that was a long lecture spread out over really 2 sessions, but I think it was valuable because there was some good stuff in there. So what do we learn about packages? First off, packages are a collection of like-purposed subroutines, some of which are exposed to the public, others which are hidden behind a black box interface. Packages being made up of 2 components, the package signature and the package body. The package signature exposing the public-facing data structures as well as the public-facing subroutines, whereas the package body contains local hidden data structures, local hidden subroutines, and then of course the details associated and the logic associated with all the publicly exposed subroutines. Very important stuff. And what's the essence? Packages are black boxes through which we expose libraries. The essence of PLSQL programming is packages. That's where you're going to make your living. All right, that concludes all of our coding examples. We're going to finish up with our next lecture wherein we're going to do a detailed review of the entire course. Please don't leave that off. It's important that we go over this stuff one more time. I'll see you then, and in the interim, you go out there and have yourself some fun, but learn something new every day. It's what's important.